Solutions are homogeneous mixtures. Homogeneous mixtures means that the properties are uniform throughout the mixture. So all homogeneous mixtures are solutions. This leaves a wide range of things that are solutions, from solids and solids, silver and gold, solid in water, solid and liquid, air, gas in a gas. These are all called solutions. The most common solution that we use around the chemistry lab are solutions in water, which we call aqueous solutions. Solutions, we usually define the greatest quantity of substance as the solvent, and all the other components as solutes. So we'll have one solvent and potentially a whole bunch of solutes, as we do when we have coffee. We categorize our solutions as either electrolytes or non-electrolytes. Electrolytes conduct electricity. Non-electrolytes do not conduct electricity. Electrolytes will consist of ionic compounds or acids as solutes. Non-electrolytes will be covalent compounds. So electrolytes, when we use that for our drinks, we're talking about the minerals that are in there that contain the ions, the ionic compounds as minerals. The concentration of solutes in the solvent can vary quite a bit, and it's limited. There's a limit to how much we can dissolve most things into a solvent, and that would be called the solubility. Is the amount of material, the maximum amount of solute that we can dissolve in a solvent. And we usually define that for numerical quantities as grams of solute per 100 mLs of solvent. Then we have two general categories, soluble and insoluble, and these vary depending on our needs. So soluble is when something has an appreciable solubility. Insoluble is when something has a minor or negligible solubility. The solubility of solids and liquids generally increase with temperature. This can be a exponential type of increase, or it can be a linear type of increase. But most solids and liquids will increase solubility with temperature. And the line here, this line would be called the saturation limit. So when the concentration is at that line, the solution is saturated. And we can usually tell a solution is saturated if we cannot dissolve any more solute in it. So there will be some undissolved solute sitting on the bottom. This happens when we try to put too much sugar into our tea. We end up with a pile of sugar at the bottom that cannot dissolve. That will be a saturated solution. If we have less than that amount, that would be unsaturated. Occasionally we can get more than that amount. We usually can get that by dissolving more at a high temperature and then cooling off. And sometimes as it crosses the saturation limit, it does not find a point to start to crystallize on, and the solution will cool down without crystallizing, and it becomes supersaturated. This is not very stable, and we can trigger the crystallization by vibration or by a seed crystal or dust or stirring. Not everything dissolves in each other. The main difference is between polar and nonpolar solvents and solutes. Polarity we'll look at separately in intermolecular forces, and it's a partial charge separation in molecules. This creates an attractive force between the molecules. Compounds that often contain oxygens, such as water, ethanol, acetic acid, are polar compounds. And other compounds, hydrocarbons, and certain other compounds, chlorinated carbons, are nonpolar. And there will be some ethers that are nonpolar. Ethers contain oxygen. So when we dissolve things in polar solvents, the molecules, the solvent molecules, will make a solvent cage around these solute particles. This will help keep the ions of table salt in solution. Otherwise, the positive and negative ions of table salt would attract each other and recrystallize out. But the water makes a solvent cage around them that keeps them in solution. If we can mix two liquids completely together, such as alcohol and water, these are miscible. If liquids that will separate out upon standing, such as oil and vinegar, they are immiscible. If we're talking about a solid not dissolving, then it would be insoluble. For dissolving things together, we use the like dissolves like rule. A solute dissolves in a solvent when they are similar in polarity. So nonpolar solutes will dissolve in nonpolar solvents. So grease is a nonpolar solute. It will dissolve in turpentine, oil, gasoline, ethyl ether, which are nonpolar solvents. Polar solvents will dissolve polar compounds and ionic compounds. So water is polar, it will dissolve table sugar, which is polar. Water is polar, it will dissolve table salt, sodium chloride, which is polar. So two liquids that will dissolve together are miscible. Two liquids that separate, like oil and vinegar, are immiscible. When we dissolve ionic compounds in solution, the ions generally separate into the individual ions. So table salt separates into sodium ions and chloride ions, and these are held separate by the solvent cage of the water molecules. Gases can dissolve in liquids. The common example of that is soda water. Soda water is carbon dioxide gas dissolved in water. The solubility of gases decrease with temperature, so warm soda will lose gas, loses fizz faster than a cold soda. So solubility decreases as temperature increases. But we get the gas in the water by putting it over the water under pressure. Solubility of the gas increases with increasing pressure. So Henry's law, which we'll study in general chem, states that the solubility is directly proportional to the partial pressure of the gas over the liquid. That creates a straight line between pressure of the gas and the concentration of the gas, and the slope would be the proportionality constant for that solubility. And when we dissolve things, sometimes they dissolve slow, sometimes they dissolve fast. Generally, if we increase the temperature, we'll increase the rate of dissolving. If we stir the solution, it will increase the rate of dissolving. That's because as it dissolves, it creates a concentration gradient in the solution. As we stir, we remove that concentration gradient so more can dissolve. And then also, if we use smaller particle size, it will dissolve faster. So confectioner sugar will dissolve faster than cubes of sugar.